Aquastats. Aquastats are commonly found on boilers. They could be either on an oil-fired boiler or a gas-fired boiler. They are the main component in the system that's going to control the water temperature of that boiler. Okay, just as the name states, aquastat. Aqua, water, stat, temperature. So your aquastats are going to have a high and a low limit to them. As the high limit, the control works like a high limit control on any other system. It's a safety. If the system gets too high, it's going to shut the system down. Okay? You could think of it like a high limit switch in a gas-fired warm air furnace. If the air temperature gets too high, it shuts the burners off. Okay? So in this case, with an aquastat, it's going to shut the system off if the boiler temperature gets too high, and that's going to usually be about 180 degrees. It's also going to act as a low limit control when the burner on it is temperature drops too low, and that is usually around 160 degrees. Okay, the simple thing of what an aquastat is, what it's going to do, it's going to maintain the minimum boiler temperature that we need it to operate at. With the low limit, it turns the burner on when the boiler temperature drops below the set point. Okay, it's going to turn the burners off when the temperature of the water reaches the set point. Okay, in the system with domestic hot water, that low limit maintains the boiler temperature when heat is not required. Okay, we call that a warm start. Think about domestic hot water. That's hot water coming out of your faucet. Okay, that's how we're able to deliver the hot water to a home in some cases. Okay, so we got to be able to have a boiler that maintains a minimum temperature in order for us to have the ability to deliver domestic hot water to the home. And that's going to usually be around 160 degrees. Your aquastats also are going to have a circulator control on them as well. And this is going to be used in systems which have domestic hot water capabilities. They are going to be prevents the circulator from running if the burner is on the low limit side. It prevents the cooler water from being circulated for heating. Okay? Why we do this is simply due for energy efficiency. We don't want to be using any more energy than we need to supply heat to a home or to supply hot water. Okay? We only want to have these things turn on when we absolutely need them to. Prevents the boiler from getting too cold for domestic hot water generation. That kind of makes sense. Okay? We don't want to have to wait and waste all of that water coming out of our faucet just before we could get any sort of hot water. So by having a boiler maintain a set temperature, we are now able to deliver hot water in a more efficient way. So how does this thing actually operate as far as a high limit and low limit control? They have a sensing bulb on them. That sensing bulb is going to be connected to a capillary tube. And those guys is what actually measures the change in temperature, and it's going to transmit that temperature change to a bellow inside the aquastat. That aquastat, that bellow, is now going to move, open and close a set of contacts inside the aquastat. So in returns to a circulator control, when there is a call for heat, that circulator control turns on the circulator. And if the temperature of the boiler gets too low, the circulator is turned off until that boiler can now warm up again and get back to the minimum running temperature that we want. Now, why do we do that? It's simply to prevent excess runtime while the boiler heats up. Again, energy efficiency. We don't want to keep the circulator running all the time because all we're doing is just circulating cold air or cold water. We don't want that. we want the boiler to maintain. So sometimes you will see on a boiler that the burner was going to run, but you'll hear the circulator not be on. It's simply due to the fact is that the circulator is off because the Aquastat's telling it to be off. Okay, your dual Aquastat controls, these guys actually have a combination. They combine the function of a high and low limit control with the circulator control all in one nice little package. Okay, it's going to have a single pole double throw switch, and that's going to be used on the low limit and circulator control with a single pole single throw switch serving as the high limit. So in the event of a high limit, burner gets too hot, single pole single throw switch opens, shuts off the burner. Okay, the single pole double throw switch is going to turn the burner on, or it's going to turn the circulator on, back and forth, either way. Your dual Aquastats, when the burner temperature is below the set point, the terminals R and B contacts are going to close because those are our low limit connections, and R and W contacts are going to open. That is our circulator. Okay, R and B is our low limit. R and W is our circulator. So when the boiler temperature is above the set point, R and B is now going to open, and R and W is going to close, turning on the circulator. So combination Aquastat controls, they're going to come in two types. You're going to have a separate, your standard Aquastat relay, and then you're going to have your triple Aquastat relay. Your Aquastat relay is combines the function of the switching relay for the circulator and the temperature control of the system. Okay, these are not going to be used on systems that do not have domestic hot water coils installed on them. Your Aquastat relay is going to contain those three items there. It's going to have a transformer to supply our control voltage, our 24 volts. It's going to have a relay on there to control the burner and circulator. It's also going to have a temperature control for our high and low limit operations. We've got to have some way to tell this thing to turn on and off. Okay, the boiler is not operating when the thermostat is not calling for heat. We call that a cold start. With your triple Aquastats, these are now going to be used in systems that are required to provide domestic hot water. Okay, some of them may also have the ability to provide zoning and zone controls to them. There are single zone models for gas and oil fired applications. You have your millivolt models for your gas millivolt applications. Okay, and this type of Aquastat will maintain a low limit temperature all year round. This is really the most common of your Aquastats that are out there, because there are many, many places out there that do require heating all year round. Industrial, commercial type applications. You will see them in your residential homes, especially if we are having domestic hot water connected to the boiler as well, because we need to be able to deliver hot water whenever it is needed. So we are going to have a triple Aquastat installed on there, because we now need to be able to maintain the boiler temperature all year round. Your triple Aquastats provide burner control when there is no call for heat, keeping the boiler warm enough for your domestic hot water use. And we call that a warm start boiler, 160 degree minimum. Okay, this is on our low limit side. Upon the call for heat, the triple Aquastat runs on the high limit side, providing very hot water for the heating circuit, 180 degrees. Okay, if the heating command is not there, thermostat is not calling for heat, the boiler will now operate on the low limit side. It will just maintain 160 degrees just for simple domestic hot water. Now, if both were calling, we needed hot water and heating, the boiler is going to operate at 180 degrees. Okay, most triple aquastats also provide circulator control. They will not allow the circulator to come on until the boiler is actually warm enough. And that is going to be turned on once the boiler reaches its low limit control, or its low limit setting. And that is 160 degrees. Wiring an aquastat, it's relatively simple. Okay, it's not too difficult to do. You have L1 and L2, and that's going to basically be your power supply. Okay, residential 120 volts. You're going to have terminals TT. That's your 24-volt thermostat connections. Your C1, C2, that's going to go to your circulators. B1 and B2 is going to be your burners. Okay, notice the association with a lot of this. You have your TT, thermostat. C goes to your circulator. B and B goes to your burner. Easy enough to associate, easy enough to wire. Voltage checks can also be easily made on your aquastats, okay, with your Honeywell L8148Es. These guys are going to have your low voltage burner controls. These are going to be going to your 24-volt gas valves. Some of these may also have your millivolt gas valves as well. Your 8148As, those are going to be most likely found on your oil-fired type boilers, because a lot of your oil burners are going to be working off of 120 volts. Okay, so we should never mix these two models, because obviously we can damage the control, we can damage the burners, we can damage the system. Here is your L8148A. And again, notice how easy everything is nicely laid out for us. Here's our circulators down here. Okay, and this even gives us a nice little diagram. See, look, circulator right there. Here is our burner right there. Here's our L1 and L2. Here's our thermostat. Okay, here's our transformer. Here's our relay. Okay, there's our sensing element, and here's our bellow right here. Okay, and here's our wires that makes our contact, our relay actually open and close based off of the sensing element, telling us what it needs and what it does not have to do. Your L8148E is slightly different, but not much. Okay, you got your L1 and L2 is down here. Your circulators is right here. Okay, notice on our burners, though, we have actually 3 prongs here between B1 and B3. That's 24 volts. Between B1 and B2 is our millivolts. Up here is our thermostat wiring, and for actually zoning, we may actually be able to wire a zone panel to this. Here is your transformer. Here's your relay. Here's your bellow right here. There's your sensing element right there. Okay, this guy sits inside the boiler, inside what we call a well, and that's how this guy is actually able to sense the boiler temperature. Okay, all aquastats use a differential control, and this allows the technician to fine-tune the control for a specific application. The differential acts as the other side of the set point, and if there was no differential on an aquastat, say set at 180 degrees, that burner would turn on at 180 and then turn off at 181 degrees. And that would actually be very wasteful and would actually cause the boiler to short cycle. We want to have a differential setting on our boilers. We do not want the burners to be turning on and off, on and off, on and off constantly. If that was to happen, we can actually risk damaging the burner, boiler, and all the components on it. So we want to have a differential. That differential is usually factory set around 10 degree differential. Okay, can we change that? Yeah, you can absolutely change it. Okay, but it depends on the specific application. That's why we have it. Okay, most of your triple aquastat controls are going to have your high limit adjustment, and that's going to usually be set to 180 degrees for residential, low limit about 160, okay, with a differential of around 10. Okay, can we adjust it like I said before? Absolutely, you can adjust it. Do you want to adjust the high limit setting on a residential boiler? No, probably not. You're going to want to keep it at about 180 and no higher, but you can adjust your low limit set point if you need to, and you can also adjust the differential if you need to. Okay, so this is what a triple aquastat actually looks like. Notice the 3 dials. Okay, up here is your differential setting. On most of your triple aquastats, you can actually set your differential up to about 25 degree differential. And again, like it says, you could do it depending on your specific application and what you're trying to achieve. Can you set it to that? Yeah, you can. But most residential and most mechanics will set them anywhere between 10 and maybe 15 for your differential. Your high limit setting is right here. This is your high limit set point. It can go up to about as high as about 220 degrees. Okay, now do you really want to go that high? Not in a residential setting, but you may see that on a commercial industrial side where it might be that high, specifically if we're using it for a boiler for manufacturing. And then you have your low limit set point. That can go down as low as 120 and about as high as about 200 degrees. We can mess around with this guy if we need to, but it's usually going to be set somewhere around 160 for our low and 180 for our high, with a differential anywhere between 10 and 15. Okay, our connections, L1 and L2, is right down here. Our B1 and B2 is actually right here, and C1 and C2 is right here. Okay, thermostat connections are up here. Transformer, relay. Okay, the R8182 is a triple aquastat. So on a warm day where only domestic hot water is being used, the system is running on a low limit operation, 160 degrees, with a differential of around 10. So sequence of operation of this guy is basically this. The boiler temperature is at 159 degrees. Nothing is going to run at that time. Okay, domestic hot water is going to start being used. The boiler temperature is now going to drop. Why? Because now the water is now being circulated. So the boiler temperature is going to drop to probably around 150 degrees. That is that 10 degree differential below the set point of 160. Once it reaches that 150 degrees, the burner is now going to start, and it's going to warm the boiler back up to 160 degrees. Once it reaches the 160 degrees, the burner is going to shut off. Now, on a call for heat, the triple aquastat is now going to run off of the high limit setting. That's 180 degrees. Okay, the burner will come on and heat the water until it reaches the high limit setting. The circulator is running since it is above the low limit setting. The burner is going to shut off at your high limit. The water temperature in the boiler will drop until it reaches 10 degrees. Again, our differential until the high limit set point, under the high limit set point. The burner will then come on again and reach the set point again and then shut off. That is now going to continue until the heating cycle is over and the thermostat satisfies. And once that happens, the burner is going to go back down to the low limit operation, again of 160 degrees. So the smaller the differential, the more the burner is going to cycle, which means the closer the water temperature will be kept to the set point. The greater the differential, the less the burner is actually going to cycle, which means you will have a greater swing in temperature. Okay, this is why we say you are going to have that plug and play and see what set points you need to set your differential to so that you can optimize and have the best heating cycle that you can actually achieve out of a boiler. It is always important to keep in mind that the Aquastat is an electrical device and should never get wet. Okay, you always have to pay close attention to that, especially when you're servicing it. Make sure that nothing is leaking on it. Make sure it doesn't have any sort of damage, anything like that. If it does, it should be replaced. We protect the control from water by temporarily covering it with a plastic bag or some sort, so that you do not have any sort of water spills going on it. Because the Aquastat does sit on the outside of the boiler. It will sit right on the face of the boiler itself. If any sort of water does happen to drip on the circuit board, it can obviously fry it.